Well, we've got supply and we've got demand, and so now we can do some analysis of competitive markets. And the analysis will have two aspects to it. One is, the intersection of supply and demand gives an equilibrium price and quantity. So that's sort of what happens. Then there's the question of how well off are we, and we can also analyze that in the supply and demand framework. So without further ado, let's just move on and talk about that. So the market equilibrium, again, that intersection of supply and demand, generates, well, the equilibrium outcomes, the price and the quantity, but it also generates some measures of well-being or welfare. And our notions of welfare are going to be measures of surplus for the participants. And then what we'll do is we'll consider various kinds of interferences in the market, things like taxes or import quotas, and we'll ask, well, what does it do to the equilibrium? What happens to price and quantity? And what happens to the well-being or welfare of market participants? That's the topic of the analysis of competitive markets. So let's start by taking a look at a free market equilibrium. So we have a market demand curve of the sort we've been working with all term. We have a market supply curve. The equilibrium occurs at the intersection, and the resulting price is this P star, Q is this Q star. So that's simply what happens at the intersection of supply and demand. Now let's talk about the well-being of market participants. Total surplus is going to be the sum of something we call consumer surplus and something we call producer surplus. So let me talk about these. First, consumer surplus. So each point along the demand curve represents some consumer's maximum willingness to pay for the good. Now keep in mind, at the equilibrium that's determined by the intersection of supply and demand, the price that gets determined is this P star. So this point here represents some consumer who's willing to pay this amount for the good, but the amount he actually pays is just down here. It's the price. Now that means that this vertical distance, the difference between the maximum willingness to pay and the actual price paid, is a benefit to the consumer, and that we call that each consumer's consumer surplus. So this vertical distance here is the surplus experienced by the consumer who has this willingness to pay, and this vertical distance here is the surplus experienced by the consumer who has this willingness to pay, and so forth. If we add up all these vertical differences, so we add these differences up across all of these purchases to get the overall consumer surplus. And the overall consumer surplus is this bluish triangle up here. There's an analogous concept called producer surplus. That's the difference between the price received by the seller and the marginal cost summed or added across all the units sold. So think about the unit here. There's some seller who has this marginal cost, but she gets this price. And so the vertical difference between those two is some surplus for the producer. And the sum of those, that whole lavender triangle, is PS, or producer surplus. Now this is a big deal. In fact, you might say the good news about markets is that with perfectly competitive markets, that is with many firms selling homogeneous products, unfettered competition actually maximizes surplus, meaning any interference in the market reduces it. Any regulation reduces surplus. Now, frankly, this is an insight that people often attribute to Adam Smith, this handsome fellow on the left here. And here's a picture of one of his very famous books, The Wealth of Nations, on the right-hand side. Prior to Smith, I think people looked at what looked like chaos in the world and thought, oh, my goodness, nothing orderly or good could be coming of all this. But what we know from economics, or what we're learning in this class, is that when we leave people to their own devices and have many sellers in a market selling homogeneous products, leaving them alone actually maximizes the surplus of market participants. And so that's a major bit of good news about markets. All right. Well, now that we've seen what's good about a perfectly competitive market on its own, let's think about what happens if we put some sort of interference into a market. And so we're going to think about putting a tax in a market, and the general topic here is tax incidence. So let's introduce it with the following idea. So let's suppose the good news is that your once every 2-week paycheck looks like this, The good news is it's $20,000 every 2 weeks, so that seems like a lot of money. That's probably going to allow you to live comfortably. But there's bad news. The bad news is that you work for the Dunder Mifflin Company. But maybe more to the point for this class, you pay taxes. So your gross pay is $20,000, and the taxes you pay are $7,000. Now, let's ask a question, and I hope you see this is going to be a trick question, but let's ask the question, how much do taxes affect your pay? Now, I think one's first impulse is to look and say, well, gee, 20 minus 7 equals 13, so taxes reduced my pay from 20 to 13, but it turns out that's not really the right answer. And to set this up a little further, you could say, well, the statutory incidence, meaning who it is who seems to be paying it, like you, who seems to be paying $7,000, looks like you, the recipient of this check, is bearing the incidence. But the real question is, how does the tax change the equilibrium in the marketplace? And it turns out that we have a model for thinking this through. The model of supply and demand allows us to think this through systematically. So, what does a tax do? A tax introduces a wedge between what buyers pay and what sellers receive. You know, if there is no tax, then there is no wedge. But if there is a tax, there is a wedge. And this allows us to ask two kinds of questions. One question is, who pays the tax? Right? And when I say that, what I mean is, compared to the no tax situation, is it the buyer who pays a higher price or the seller who receives a lower price? And you'll see what I mean in a minute. The other kind of question we can ask is, what are the efficiency consequences of the tax? That is, think back to those measures of surplus, producer surplus and consumer surplus. Well, what happens to the surpluses experienced by society when we put a tax in there? And one of the answers is going to have to do with this concept deadweight loss that we'll define shortly. All right, well, let's start with a situation without a tax. So with no tax, the equilibrium occurs at this intersection of supply and demand. And again, quantity is Q star, price is P star. You know, one characteristic of the equilibrium, one way to say what it is that, you know, it occurs at the price, or rather at the quantity where the price on the demand curve equals the price on the supply curve. Right? So there's no wedge between those two. Well, now let's think about a tax of T per unit. So little t is going to be the tax per unit. So how do we find equilibrium? Well, now what a tax really means is that whatever the buyer pays, we've got to subtract T from it to get what the seller receives. So that means with the tax in place, we can find the equilibrium at the quantity where the buyer price exceeds what the sellers receive by T per unit. So we're looking for a place where the vertical distance between the blue demand curve and the red supply curve is this amount T. And sure enough, here it is. So what that means is QT is the new equilibrium. So the Q star was the equilibrium with no tax, the equilibrium quantity, that is. QT is the equilibrium with the tax. Now, what else is new? P star was the price both paid by buyers and received by sellers when there was no tax. When there's a tax, though, PD, denoted D because it's the price from the demand curve, that's what buyers pay. So PD equals price paid by buyers. PS, though, is the price received by sellers, and the distance between them, or the difference between them, is T. And we can also label these regions. So I've added an A and a B and a C and a D and an E and an F. We've labeled all these regions, and we can think about the well-being of consumers and producers in this market. So let's first think about the well-being of those parties when there's no tax. When there's no tax, consumer surplus is A plus B plus C. Now let's just talk that through for a second. When there's no tax, the price is P star. And the valuations along the demand curve, well, along the blue demand curve are the valuations. So the surplus is this whole distance between the blue demand curve and this red line for the price, P star. And so it's that whole triangle ABC. And on the producer side, when there's no tax, this P star is what producers receive. Their marginal costs are along this red supply curve, and the triangle between this price and this red supply curve, DEF, is producer surplus. Now, once the tax is in place, things are a little different. When the tax is in place, consumers now pay PD, and they only consume QT units. So how much surplus is there? Well, now it's just the distance between here and here summed across all these units in A, so it's just A. And the producer's surplus, well, now remember, producers, although consumers pay PD, producers only receive PD minus T, or PS. So the surplus for producers is the difference between what they receive and their marginal costs down here. And summing that across all these units gives us just region F. Well, that leaves a few regions unaccounted for, so let's figure out what's going on here. So what about the rest? Well, one part of the rest is tax revenue. So think about tax revenue. In the presence of the tax, QT units are traded, and there's a tax of T per unit. So QT times T is tax revenue. That also corresponds to regions B plus D. That then leaves regions C and E unaccounted for. C and E used to belong to surplus. They used to be surplus for consumers or producers. In particular, C was with consumers and E was with producers. But now they're lost. Nobody gets them. So we're going to call them deadweight loss. One other way to think about them, so think about when there's no tax. This situation right here is a situation, this unit that could have been transacted is a unit where there's someone willing to pay this much, but it only costs this much, and so this transaction occurs and produces surplus for both parties. When there's a tax, even though somebody values this good more than it costs, they don't value the good by enough more than it costs for the transaction to occur. So the tax prevents all these triangles of surplus from occurring. So those are just missing. They're gone from consumers, gone from producers. And let me just say another way to think about what deadweight loss is. It's not really another way, it's the same way, but different words. A deadweight loss is a loss to one party that's not offset by a gain to another party. All right, let's work through an example. So how would one actually do a problem involving this kind of analysis? Well, here's how you do it. So first you have a demand curve. P equals 10 minus Q. But now, since there will be a difference between the price paid by buyers and the price received by sellers, when I write the demand curve, I'll denote the P as P sub D. The supply curve, let's say, is P equals 2 plus Q. And again, because there's a different price received by sellers than the one paid by buyers, I'll denote the price on the supply curve as P sub S. First, let's find the equilibrium without the tax. And so how do we do that? Well, we just find the quantity where the price on the demand curve equals the price on the supply curve. So that means substituting here. 10 minus Q, that's the price on the demand curve, equals 2 plus Q, which is the price on the supply curve. Solving that, we get 10 minus Q equals 2Q, or Q equals 4, and P equals 6. Now, how do we get P equals 6 from Q equals 4? And let me mention this because it becomes a little different when there is a tax. So take the demand curve. Q equals 4, then PD equals 10 minus 4, and that's 6. You could also get it from the supply curve. PS equals 2 plus 4, which is 6. So it's 6 either way, and it's correct. But now let's add the tax. Let's now find the equilibrium when there's a tax of 4 per unit. So the key here is that now we look for the quantity where the difference, so let's be clear, this is like a bullet point from PowerPoint, so let me just make sure it's not there. We're looking for the quantity where the difference between the price on the demand curve and the price on the supply curve equals the amount of the tax, or 4. So that means here, and again, let's get rid of these misleading bullets. What we do is we plug in PD, 10 minus Q, and we plug in PS, so minus the quantity of PS, and we set it equal to 4. And if we solve that out, we end up with Q equals 2. So another misleading bullet point here. Now, having found Q equals 2, we now have to find the price. But here it gets a tiny bit tricky, because remember, there's a difference between the price paid by buyers and the price received by sellers. And that difference better be the amount of the tax, or else we made a mistake. So let's plug in Q equals 2 to the demand curve. So PD equals 10 minus 2, that's 8. Let's plug it into the supply curve. PS equals 2 plus 2, and that's 4. And the good news is that 8 minus 4 equals the amount of the tax, 4 per unit. So yes, we got this right. We can also look at a picture. And sure enough, in this picture, we first have the no tax equilibrium, where we have the intersection of supply and demand right here, the associated Q star of 4, and the associated no tax price of 6. Now when we look for a quantity where the vertical distance between demand and supply is 4, we find that quantity of 2. The associated price on the demand curve is 8. The associated price on the supply curve is 4. Now we can calculate out these regions if we want to. Region B is a rectangle, and how do we calculate it? Well, the height of this rectangle is 8 minus 6, or 2. The base of this rectangle is 2, so that region is equal to 4. Region C is a triangle. How do we do that one? Well, triangle, remember, is if we have the height here and the base here, triangle area equals 1/2 base times height. So in this case, it's 1/2 times the height, which is 8 minus 6, or 2, times the base, which is 4 minus 2, or 2, and we get 2. And one could calculate D and E and other regions analogously. So in this problem, the losses to consumers and producers collectively total 12. So if you were to calculate B and C, which is what consumers lose with the imposition of a tax, you'd get 6. And I'll say minus 6 because it's a loss. The loss to producers would be 6. So delta PS, that is the change in producer surplus, is minus 6. Some of this is a transfer to the government. Tax revenue is 8. Well, how do I know that? I know that because this vertical distance, 8 minus 4, is 4. Horizontal distance is 2. 2 times 4 is 8. But the remainder, so of the total 12 that got lost, 8 went over to the government, but 4 is just lost. And so 4 is deadweight loss. And by the way, that's also the sum of regions C and E. Now, a related topic is tax burden. The question here being, who pays a tax? And what it depends on is the relative elasticities of demand and supply. And so this is going to be the question of how does the equilibrium price change from the situation where there is no tax to the situation where there is a tax. So to make this point, I'll draw a few curves, or I'll make a few diagrams with relatively different relative elasticities of demand and supply. So here let's start with what I'd say relatively elastic demand. So the demand curve is nearly flat. The supply curve is has a common steepness to it. So here when we impose a tax, look what happens. And let's focus on the price axis. So P star is the original intersection of supply and demand. Now we impose this tax, and look what happens. PD minus PS is, of course, just equal to T. But look, the price paid by consumers went from P star to PD. It only went up a little bit, whereas the price received by sellers, the price received by sellers went down a lot. So here you'd say that the sellers bore most of the tax. Okay, so sellers bore most of the tax. And this is the case with relatively elastic demand, which means that the suppliers or sellers are more inelastic. Let's consider a different case where we have relatively elastic supply and therefore relatively inelastic demand. Well, look what happens here. Here's the intersection, the equilibrium without a tax. There's P star. But now after the tax, what sellers receive only went down a little bit, but what buyers paid went up a lot. What's going on here? Well, what's going on here is that the relatively inelastic party ends up bearing most of the tax. So the punchline on tax incidence is that the relatively inelastic party bears, let's spell well, most of the tax. Now the intuition for that is as follows. The elastic party is a party that's able to substitute away, whereas the inelastic party is kind of stuck in some sense. So whoever's kind of stuck is the one on whom the tax really mainly gets borne. So in this picture, where you see a pretty inelastic demand curve, the buyers pay the tax, whereas when the supply curve's pretty inelastic, the sellers pay the tax. And note that when I say pay the tax, I don't mean they send the check to the government, because it could be the case here that even though the buyers are paying the tax, it could be the sellers sending the check, but what matters is how the equilibrium prices have changed, not who seems to pay the check. All right, what are the takeaways from our section of analysis of competitive markets? Well, a couple of things. First, as we said, the good news about markets was that unregulated, perfectly competitive markets maximize the welfare of market participants. When we want to think about the effect of a tax, it requires thinking about what the new equilibrium is. And what a tax is, it's a wedge between the price on the demand curve and the price on the supply curve, or the price paid by buyers versus the price received by sellers. And what a tax does is it reduces the quantity, but then it raises the price paid by the buyer and reduces the price received by the seller. But how much it does to those parties depends on who's relatively more inelastic. And taxes are borne more by the inelastic parties, or in this case, the inelastic party.